I mean, Oleg is not joining. He's not available right now. But we have two more participants. I don't know if they will join. So let's wait 2 minutes and then we start, okay? Okay, so then let's just start. I will share my screen. Oh, there we go. So just give me an information if you can see the screen. Can you see it? The desktop now, right now? Hello? Nikolai, Victor, can you see it?
Alexander, yes,
we can. Okay, sorry.
Yes, we see.
Just saw the chat now.
It's just pretty well picture with vacation.
Very nice, right? Yeah, that's what I would like to talk about today. Now let's start. Okay, so first of all, welcome. Welcome. My name is Alex. Nikolai, you know me. We had contact sometimes for our other colleagues here. My name is Alex. I'm service engineer and also I'm doing some service trainings for our emergency lighting systems. Today we will cover the dual guard system itself. My contact details. I mean, you have it anyway. So what we would like to do today is we'd like to do a short presentation. I will show you a few slides and later on we will switch to a live demonstration, right? There we go. Okay, so this is what we like to do today. First part here, everything is covered with this presentation part. Then we go to the live demonstration. And later on, we can also talk about the PC software. So I will have a few questions, to you as well. If you have questions, please ask directly. You can also write it in the chat. I would just check if I'm able to see. I hopefully I see a pop up here, and I see that you write a message, Victor, because you have you don't have a microphone right now, but you can also write it in the chat, and I will answer to it. Don't wait until the end. Please ask directly, and I like if it's a conversation, that I don't need to talk alone the whole time. I think I'm correct. You all have good experience with ZBS. We will not cover ZBS. We will compare both systems today. So this is a big part, compare of ZBS and DGS, and also what's new and what's the new modules, what changed actually, and yeah, what to cover. There's someone in the waiting area. Let's check that we invite him. Hello, good morning. Okay, microphone is muted, but I think he should be able to understand me. Okay, there we go. So yeah, feel free to ask questions directly. My question to you is, do you have any experience with the dual guard yet? Do you have a test system? Did you ever stand in front of one dual guard system, or is it absolutely new for you?
From our side, we have implemented one project with dual guard, but it's only a project documentation yet. But nothing sales. It's new also for us.
Okay, so you did not do commissioning, programming. You didn't see the overview and stuff like that.
No, we didn't see the samples. We didn't see anything. Just some documentation.
Okay, perfect. Then it's good. Okay, I would say let's start. So this is very basic, and yeah, feel free to ask, because yeah, I like it. So let's start. So first, just an overview. This is how the system looks like right now. You may see a picture like this. Just would like to cover the main difference, and the main difference is that the HMI is located here in the front of the cabinet, which means that you can see all system details from outside the cabinet. So you don't need to open the cabinet, right? So this is one of the biggest differences of the system. First, we have a HMI which is located in the cabinet. So let's start to compare ZBS and dual guard a little bit. As I said, the main thing is we have a touch HMI now in the dual guard, and the ZBS still has the CU CGS. And yeah, what's different? Well, the whole menu structure has been revised. It's new for sure. You will find all the menus you know from the ZBS as well here, and some additional points, but it's a little bit revised. The structure is a little bit different. In the dual guard system, you have 4 different user accounts. Standard login, if you receive a new panel, is this one here. Username is admin, password is Ethan. Not very hard. Okay, so this is the first login as an admin account, and with the admin account, you are an expert. You can do all the changes, you can program the whole system, and you can destroy the system, whatever you want. Okay, we have 4 different user accounts there. We have an operator. The operator is just, for the customer who operates the system, who should only see the status and who should not be able to program the system. Okay, that's the operator. We have an untrained specialist, instructed specialist. This is something you can say, okay, the installer has an account for an instructed specialist, so he's able to do the programming, but he's not able to change or to delete the whole configuration, to the system, to restore the system. And as you can see, we don't have any SD card anymore, right? Control unit CGS has the SD card slot. The dual guard S system don't have it right now. We have a USB port at the panel. I will show it later to you. One more big difference is that we have the web interface, which is included in the system right now. So the web module we all know from the ZBS, LP Star, ATS, whatever. We don't need it anymore, because now we have a system. You can connect your computer to the system, and then you have the web access. You can program, you can do everything. It's like you would stand in front of the system. I will show it to you later. You can see the status of the system, and you can program functions, stuff like that. So this is quite nice. If if the customer is 200 kilometers away, you can also support via remote. if he gives you access to the computer, you know, via Teams, via TeamViewer, you can easily support him just with an internet connection. And this is very, very good. I did it a few times now for customers here in Germany, as well as customers in England, so Great Britain. And yeah, that's very good. So we don't need a web module anymore. But due to the functionality as a web interface, we also need to cover some Eden cybersecurity. Eden cybersecurity means the system is absolutely safe and secured for, attacks, let's say for cyber attacks or stuff like that. You are not able to do anything at the system without enter your username and password, without login. This needs to be done because we can connect to the system via Ethernet. And you know, if someone would like to attack your system, your company, whatever, and he has access to the safety lightning, you know, he should never be able to destroy everything or turn everything off. That's why you need to log in yourself. Okay, so basically we have two HMI panels. We have a bigger and a smaller one. We have 5.3 inch and 7 inch. If you use web access very often, 4.3 inch is enough. But for sure, if you have 7 inch, it's quite nice to stand in front of a 7 inch system instead of a 4.3, because you can read everything a little bit easier. And you can press the buttons a little bit easier for sure. But this depends on where you would like to use the display. You know, if it's like in a school, nobody needs to take a look to the HMI very often. You can easily use a 4.3 inch HMI, and you can see everything here as well. My personal view is I prefer 7 inches. Here's what I mentioned before. You can see at the back of the HMI that there is a small USB port. Okay. With this USB port, you can transfer the configuration to the system if you would like to configure the system with the PC software. You will see later that we can program the whole system live, web-based. Then you don't need it. But if you would like to download the logbook, or if you like to do the programming like you did in the ZBS system with the PC software, you will transfer everything with this USB port. This is just the Ethernet connection, the link from the HMI to the system. I will show later. Okay, so let's talk about the internal modules, and I will cover the new modules basically, mainly. Maybe there are some slides. We can skip it then. But let's talk about the ACU. The ACU is the new control unit. You could say it like that because we don't have a control unit right now. I said it, we have the HMI. But the HMI don't have any connection terminals, right? So the HMI is connected to the ACU, and this is where we connect all what we did connect in the past on the control unit. And I would like to cover the terminals step by step. Some of them you recognize, you already know them, you know, like RS485, for example, and there are some new. So let's cover this first. Let's start on the top left here. You see that we have internal resistors here, like we had on our SOU modules. We have two bus technologies. We have the ACU bus and the RS485 bus. Both needs to have a termination at the end and at the beginning, right? So if you do the termination here, you can activate the internal resistance easily by pushing this upwards, and then you have the resistor. The RS485 bus is still the same. We need it for 3PMIO modules, for external SOU modules. It's absolutely the same like we had in the ZBS technology, but this is new. This is the ACU bus. And you could say that the ACU bus is the new CGS bus. That's nearly correct, not 100%, because very important information, the ACU bus is only used to connect ACUs together. Okay, if you would like to do a substation setup, you use this ACU bus to connect them together. Visualization is a different thing. That's why we call it ACU bus, because it's only for substation setup for ACUs. Okay, so we have
sorry, Alexander, have question. Have you cancelled the long walks, because it was really sometimes a problem with long walks? You have switched the protocol?
Yes, we did. We switched to this ACU bus is a CAN communication, a CAN bus. Okay, but I will say when I talk about this bus here, I will say ACU bus, because it's very important. You will see later why. You will see later why I say that. This is very important, that you don't connect everything, something else than an ACU to this bus. Okay, so let's say this is not a CAN communication. Let's say this is ACU bus. Okay, we have a CAN bus as well. I will talk about it later. But yeah, you are right. We changed it because the LON protocol is very slow, right? And we would like to do step forwards as well. You might hear something about the Vision Guard. Did you? Do you know what Vision Guard is?
A little bit, yeah, actually.
Okay, so the Vision Guard is visualization software, and the Vision Guard is a very, very, very quick. If we talk very fast, if we talk about the data transmission, so the Vision Guard reacts live. If you change something here, the Vision Guard will react. And this is as well because we use a new busnet technology here. We use ACU buses for each system, and then we talk about the Ethernet connection to the system. So we try to leave the LON protocol. And in the future, if we talk about the next 5 or 10 years, the CAN communication will be implemented for the whole system, which means there will be someday we will talk about CAN communication only, and the RS485 bus maybe will be gone as well. Okay. Okay, so here we have our bus connection, right? It's for the ACU bus. This one for the RS485 bus. This one, next to it, we have inputs. In total, 6 here. And if we jump forward, we have input number 7 and input number 8 here. These inputs, you might miss S3, S4, and S1, S2. Okay, so this inputs needs to be programmed all the time. If you have phase monitoring with S3, S4 with a conventional phase monitor, you need to program it. You can say, okay, I would like to use this input number 1 as 3-phase monitoring. Then you can program it, and after you did it, this works like S3, S4. As well, if you say, okay, I would like to use a key switch for the system to block the device, an F3 interface, you can say, I would like to use the second input for this function, and so on. So now you are absolutely free to program your functionality to the inputs. It could be S1, S2, or S3, S4, but it could also be something like lightning switches, run a function test, block the device, stuff like that. Everything can be programmed to the inputs. And one very, very important thing is that these are digital inputs. You don't need to connect separate 24 volts to these inputs. You just need to close these contacts here. And after that, the input will react, okay? So no external voltage. Very important, because when we talk about the ZBS technology and the Z inputs, you all know it, we used 24 volt, but not anymore. Now these are digital inputs, just close the contact. Okay. Next to it, we have our relay outputs. I don't need to cover this, I think. You can connect the F3 interface to it. You can connect your building management system to it, whatever you want. You can free program it, free assign them. yeah, what's new, you see that each relay has their own COM contact. So now we have absolutely, yeah, separated relays. We don't have the C0 contact you might know from the ZBS technology. Okay. On the bottom left, you see, you cannot see it very good, but these are two Ethernet connections. One is the Ethernet in connection. The Ethernet in connection is only used when you would like to connect your computer to the system and you would like to use the web server for programming or to check the status. Okay. The Ethernet in connection is as well used when you run a vision guard. So if you would like to monitor the system with a vision guard, you use the Ethernet connection. You don't use the ACU bus, okay? You use the Ethernet connection for vision guard. And the second one is the HMI out, which is clear. This is the connection from the ACU to the HMI. Okay. 24-volt power supply is clear. Input number 7, input number 8. I already talked about it. It's the same. It's just located here. You know, if you have a fan monitoring or something like that, which is an E30 systems temperature measurement, stuff like that, this is located here. The output transistor here is not used actually. This is just prepared for the future because the hardware design is finished for sure, but the functionality of this output transistor is not able yet. You cannot program it. And last but not least, we have our backplane connection, because you might recognize that this module is designed to be used on a DIN rail. You can see it here, right? This is connected, or this is installed on a DIN rail. It's not installed on the rack like the control unit was, which means we need a connection from this module to the SKU modules. And this is done via a cable which goes from this port here to the PSU module. Okay.
I have a question, sorry.
Mm-hmm.
Two questions. So input 7 and input 8, is it analog input for some kind of sensors and so on?
No, it's a digital input as well. It's just located here because they would like to have the relays on the top right. This is, you know, digital input standard used if you have, I don't know, an E30 cabinet, you know, you order an E30 cabinet and the temperature sensors are not analog connected to it, just the relay outputs, you know, in case of a failure. This is a digital input as well. You can program it as well to S3, S4 if you would like to do it.
Okay, and second question, output transmission. Is this the power supply of 24 voltage for outside models, external models, or what?
Yeah, this is not used yet. This is, you know, you can see Q5 and Q6, so we also have relay inside here. The functionality of these terminals are not specified yet. There will. Okay. This is just because you ask now. We don't, or I don't know the 100% functionality, because this is just a design thing from the R&D for the future. This will be something. This will be something like you said, that you can connect more. Let's say you have special systems. This is just for special systems. You have two ACUs in one cabinet, you know, but the power supply should be from one point and stuff like that. This will be used in the future, but right now this don't have any functionality.
Okay, clear, Alexander. Go on.
I just missed one thing. The RS485 bus is still the same, right? The length is still 1200 and 120 ohm. The ACU bus has 120 ohm as well. It's not very important because you have the internal resistor, so you don't need separate resistor, just for your information. So 120 ohm and 900 meters. So it's the same length we had in the CGS bus. Okay. Just drink something. Okay, the backplane connection, let's go back to it. So as I said, you need a connection to the SKU modules, to all the internal modules. This is how it works. You have a connection from this terminal to the backplane, and this is used, or this is done with the PSU module. The PSU module is developed a long time now. It replaces the DC-DC converter. And as you can see here, there is a connection from the backplane connection directly to the PSU, to the bus in terminal. And through this cable, we have our RS485 connection right now, and we have a CAN communication. Here we have a CAN communication as well, because the PSU and the ACU talk via the CAN protocol. Okay. The PSU module, yeah, it replaces the DC-DC converter or DCM. I just want to figure out some important things. In general, this module is much more intelligent. You know, you have detailed information when you use it with the dual guard system. You can see high temperatures, critical temperatures. You can see voltages, stuff like that. Second thing is that this module has a passive ventilation. Okay, so there's no ventilation inside, which can cause a failure and which can cause overheating of the product, which is quite nice. You might recognize that we don't have a dip switch anymore here. You cannot turn this module on and off with this dip switch we all know from the DCM. If you would like to turn on the module, or you would like to turn it off, just press the service button for 4 or 5 seconds and the system will turn off or on. Okay. It's still possible to use an AC module for sure. Just connect it. One additional thing is that the PSU monitors the AC module right now. We can see it later on. So in case that you use AC modules in the substation and the AC module is broken, the PSU will recognize it and sends out an information and a failure message to the system. So you will see early that there is something wrong with the module. On the bottom right, we have a PSU OK contact. When you use the PSU with an ACU with the dual guard system, you don't need this contact because it communicates via the bus to the dual guard system and you can see detailed information. But if you run a PSU in a ZBS cabinet, you don't have bus communication, then you can use the PSU OK contact connected to Z. Connected to Z inputs. Maybe you should mute your microphone. We can hear it. One second, I just mute the microphone. So Victor, your microphone is working right now. There we go. Sorry, just mute you, Victor. There we go. Let's go on. Yeah, the PSU contact can be used with the combination of PSU and ZBS. Just connect this contact to a Z input. Okay. Go with 24 volts through this contact. This contact is closed when you have a failure. Okay, you can use it as an external failure on a ZBS, for example. Okay. So let's talk about the modules in general. We all know BCM and CM modules, so I don't need to cover this in detail. The BCM changed from BCM to BCM.1. What does it mean? I will cover it in the pages on the slides which come now, because the main difference actually is this one here. Unfortunately, I see that this is not very clear, to be honest. I'm sorry about it. Not a good picture. I would change it, but not necessary. Why did we develop the new BCM module? I mean, the old BCM module worked fine, right? But we did it because there is a draft, there's a requirement in the EN 50171, which says that you should be able to monitor more strings, up to 4 strings, when you have more than 1 string on a ZBS or on a central battery system. Okay, in general, this is not so bad because it leads to a more safer system, right? And you get much more precise assignment in case of failures, which means, okay, let's say you have a battery interruption failure because one battery is broken, right? But it's not a interruption in total, it's just one battery, and the system recognizes, oh, there's something wrong. When you have a system with 4 strings and you just have one, the old technology, one measurement shunt, you need to check all the 4 battery strings to find out which battery it is. When you have this string monitoring, the BCM will say, okay, I have a failure in string number 3, and then you have only to check this battery string. So it's it's faster as well. So you will find out which battery is the problem much faster. Important, each battery string for sure has their own measurement shunt. Actually, and in the past, we had one measurement shunt installed in the DC disconnector. If you use string monitoring for more than 1 battery string, you need to locate this next to the batteries. And the maximum length between the BCM and this measurement shunt is 30 meters. Okay, these measurement shunts are then installed in the battery connection unit. Okay, and the length should not be higher than 30 meters from the measurement shunt connection from the BCM to the measurement shunt. And there we go. Just would like to show you one of this distribution panel battery connection box, how it looks like, So this is how it looks like now. You have your 4 DC connectors, right? Inside the DC connectors, you have the measurement shunts, 4 in total here, and the connection from the BCM to this measurement shunts are done with these terminals, and the length from here to the BCM should not be higher than 30 meters. This module is a BDM module. I will talk about it later on. It's just, it's not necessary for the battery string monitoring, so I would not like to cover it right now. Let's talk about the terminals. I don't need to cover this because you all know the top terminals of the BCM. We still have potential free contacts and the connection for the boosters. Everything's good, but there are changes at the bottom. I mean, we use the BCM 0.1 in ZBS systems for a longer time now as well. So you all see a BCM. Just would like to cover the changes here. We still have the CCB bus connection. I think it's clear. And then you have your connection terminals for the measurement shunts. 4 in total. Again, maximum 30 meters to the measurement shunt, right? And we have our temperature connection. You might miss the 24-volt terminal. It's gone. We don't need it anymore because the BCM 0.1 module itself uses the 24-volt, which comes from behind, okay, through the rack. Okay, in general, for SKU modules in total, we also changed the module housing. Well, normally I would not like to cover it, but it's absolutely interesting how much this changes, because I just like to talk about this blue box here, because we see a good comparing of dual guard system and ZBS system. If you have a dual guard system with a 35-degree environment temperature, you have plus 45 degree at 100% load, okay? Compared with ZBS, same environment temperature, you have 53 degrees. I mean, it's higher than this, but look at this, it's 30% load. So just by change the housing that you have bigger ventilation slits, we have such a good situation regarding the temperature. And this is, yeah, interesting. I did not thought this, but yeah, it works for sure. If you have bigger ventilation slits during the installation process, you need to ensure that, you know, the waste, if you connect the cables and stuff like that, that nothing falls inside this, especially not cables and stuff like that, to avoid short circuits inside the module. But I mean, yeah, if you do the installation process, or if the installer do the installation process, he just should cover this and here work safety. Not only the module housing with the bigger ventilation slips change it, as well we have the snap-on technology right now for dual guard systems. Okay, you don't need the screw, you can easily snap on this module. To be honest, if you do it the first time and you would like to disconnect a module to exchange it, it's you need to be comfortable with this as well. But yeah, you don't need screwdriver. You don't need to install it with a screw. You can easily snap it on. Everything's good. Okay, still the three types of SKUs. You all know that, as well as SOU modules. So these are the presentation slides I don't need to cover, I think. Correct me if I'm wrong, but I don't need to explain the SOU modules, right? You all know what it is. Because the SAU.1 module is still the same, like the ZBS, and I would like to give you new informations now. Okay, let's talk about the RS485 bus. As I said, it's still the same like ZBS, right? Need to change this picture here to ACU, but yeah, just as an overview, we have a linear bus, so no branch cables, right? We have internal resistors in the modules. You need to check that the termination is done correctly. It's 120 ohm. The maximum length is 1,200 meters. And here, this is the same we had with ZBS. This is a new one. This is the ACU bus technology as well, linear. It's as well 120 ohm termination, and we have a maximum length of 900 meter. I mentioned it before, but this is how it looks like. You can connect up to 120 ACU modules actually to the system, so the system is able to find 120 ACU modules. Three PM module and 3 PMIO modules changed as well. You all know this. What's new? New is the test button. Okay, so now you have a test button where you can check if the mains failure detection and the switching of the relay in this scenario works fine. So just press the test button and check, see if the module reacts correctly. Functionality of the differential current monitoring is clear, I think. Still need 1 kilo ohm resistor at the end of the line, right? This should not be installed inside the cabinet. It should be at the end. Yeah, this is how the three-phase monitor. Correct me if you need more information, but if my informations are correct, you all know how this works, and I don't like to. Yeah, this is boring for you. 3 PMIO module, the functionality is still the same. So this is a basic presentation in general. The RCM had a redesign as well. In general, the functionality is the same, but the surface mounted housing is a little bit smaller, right? For sure, you need to check the resistance inside. If you have a ZBS disk system, dual guard LP star system, turn it on. If you have an older one, turn it off. That's it. That's easy. And then, yeah, it's connected to the dual guard system. Let's talk about some new functionalities again. Battery block monitoring. So in the past, We didn't have any battery block monitoring system from Eden. So now we implemented it. General information, it's a wireless communication, right? We have a negative pole temperature measurement. And with this battery block monitoring, you can earn statistical details of the system and of the batteries. This is how it looks like. In a short example, you have one menu where you can see, okay, I have my 18 battery blocks, I have the temperature and the voltage, you can see it here, right? And if you click on one of those battery sensors, you can see more detailed information of the battery. You have warning messages, which are shown in a yellow symbol, and you have alarm messages, which are red. The values for this warning and alarm messages are pre-programmable. So you can go into the program and you can say, okay, I would like to get a warning message in case of 10 or 15% difference from the average temperature, for example. Or you can say, I would like to have it at 30%, for example. Okay. Important, the measurements and the difference relates to the average voltage or average temperature. You have a history as well, as you can see it here. Unfortunately, this is not correct, right? 654 volt is absolutely wrong. And this is the picture from the beginning. Expert user is E, I need to change this sometimes, but this shows the warning message quite nice, because you can see here that the voltage is at 1229, while the voltage of each other battery block is higher, about 14.3 volts. Okay, how does it work? These are the modules we use. We have a BDM module. This is the head of the intelligence, you could say, okay? So this is the BDM module. This communicates to the battery sensors. The BDM module is connected next to the ACU in the best case scenario, okay? So if you have a compact system and you have the ACU installed on the normal DIN rail, the BDM should be installed next to it. As you can see here, there is a backplane, and this backplane contains a bus connection, okay? So what does it mean? The communication between the BDM and the ACU works, and then we come back to your question regarding the LON bus and the CAN bus. Okay, the communication between those two modules are a CAN communication as well, but it's very important. You cannot connect the bus of the BDM to the ACU bus here, okay? This bus technology is different. So it needs to be placed next to the ACU, then you have this DIN rail, and the connection of the bus goes through the conductor tracks behind to the ACU module, and they communicate to each other. That's fine. If you have the scenario that the BDM cannot be connected next to the ACU module, I will show some pictures later as well, then you need the CAN bus adapter. But please keep in your mind, if you connect a BDM to an ACU, don't use these contacts here. Don't use the ACU bus. Very important. The thing is that the bus technology is the same. Both are CAN bus technologies, but they are different how they work. Okay. On the other side, we have the battery sensor. This is the battery sensor, which is located on each block. Okay, we do the temperature measurement at the negative pole of the battery, and this provides very, very accurate measurements. And it's not only the temperature of the environment, it's the best possible measured temperature you can earn. Because if you take a look to other battery block monitoring systems from other companies, most of the time the battery block sensor is glued on the battery block, you know, and what you measure is surface temperatures or environment temperatures. But with this measurement method, you get good information about the actual battery temperature. Due to this negative pole temperature measurement, it's very important that you don't change the length or the thickness of the minus cable here, because this has a defined length and thickness. You know, if you extend it manually, the temperature measurements would be wrong for sure. Okay. Each sensor has your indication LEDs to get information of the status. You know, you can see it here. It's flashing when the module transmits some data. It's flashing when you have an error, or it's flashing when you have a communication to the BDM. Okay, let's talk about the scenarios. So again, this is the best case scenario because the BDM is located next to the ACU. We have the connection through the backplane, everything is fine. Okay, BDM connected to the ACU, backplane connection, everything is good. The communication from the BDM to the battery block sensors is wireless. This works via Zigbee network. You know, it's like your wireless network at home, 2.4 gigahertz, and here you can cover up to 15 meters. So between this BBM module and the last sensor, it should not be higher than 15 meters. Okay. And now we talk about the scenario where this is not possible, because when you have a separate room for the batteries, for example, or you have, I don't know, 5 walls behind the BDM and the sensors, you need to do something. Wireless won't work. Then we have something like this. This is possible as well, okay? And as I said before, then you need the CAN adapter. The CAN adapter communicates through the backplane with the ACU, and then you can use the hardwired connection from the CAN adapter to the BDM, and the BDM can be located next to the batteries. That this is less than 15 meters. I need to write it down. I will like to change the presentation. 1 second, because I would like to cover this. I would like to cover the which page is it? 58 meters. Sorry, but I think it would be nice if I write the 15 meters here as well. So between this point and this point should not be more than 15 meters. Okay. In total, you can connect 72 BBS sensors to one BDM right now. In the future, there will be the possibility to use more, but actually, as well as the BCM is only able to communicate with maximum of 72 batteries when you have 4 battery string monitoring. Yeah, this is the maximum amount right now. So this is what we got. BDM communicates with the BBS sensor. This is how it looks like in real life. So no schematic overview. As you can see, the wire is a little bit short here, but this works fine. These are the sensors we have right now for our standard batteries. 14 ampere hour is not available anymore. So this battery type is not available anymore. So this is not correct. But as you can see, we have battery block sensors with M6 connection, and we have battery block sensors with M8 connection. As I said, you should never change it by your own, because if you change the connection, the temperature coefficient would be changed, and the measurement behind it, the math, you know, regarding the temperature would be wrong. Okay, this is this is an example from our training room. BDM communicates wireless through BBS sensors. The BBS sensors communicates back wireless. As you can see, this, yeah, it could be a little bit better. This was just a quick picture which which my colleague sent me. But imagine how it would look like if you would have a bus cable as well here, you know, a bus cable through all the modules, through the cabinet and back to the BDM. So the wireless connection is the best way to do battery block measurements. Okay. As you can see here, this is the external BDM, you know, it's not located next to the ACU. So we have a hardwired connection here, bus terminal, 24-volt power supply. And we have two relay outputs, one for warning messages and one for failure messages. Okay. So that's all first for the BDM and BBS and theoretical part as the theoretic part. So let's talk about new functionalities of the dual guard. When we take a look to the ZBS, we were not able to switch on luminaires which are located on a substation when the DLS was connected to the main station. Okay, you can only switch luminaires on that system where the DLS module is located. In the dual guard system, we have something which is called cross-wide binding function, or I will say it publishing and subscribing. And with this functionality, you can publish or you can subscribe modules from other systems. So let's say you have a dual guard system number 1, dual guard system number 2, which is a substation, and you have a dual guard system number 32 as well, whatever. On dual guard system number 1, you have your 3PMIO module connected, and you have a switch, and with this switch, you would like to turn on a luminaire. If you would like to do it on a dual guard system number 1, very easy. It's like we did in the past as well. But from now on, you are able to switch or to use this I/O input, which is connected to the dual guard system number 1, to turn on a luminaire on system number 32. Okay, you can publish this module, you can subscribe it here and do everything, whatever you want, turn on luminaires, turn off, whatever. So this is quite nice, especially when the installer did forget to install cables, you know, and you know you have an installation where all 3PMIO modules are installed and connected to one station. Some examples how to use this publish and subscribing function on site. As you can see here, we have a main station with a BCM and we have a substation without a BCM. When you have a dual guard system, the BCM of the main station, because this module, as I said, is an external module, receives the battery data from the BCM in the main cabinet. For example, when this BCM recognizes the deep discharge of the battery, it communicates through the bus to the substation, and the substation will say, okay, I have a deep discharge protection right now. To do it like that, you need to go to the menu, charger setup, press this little button for publish. So this system now provides the battery data to all substations who would like to subscribe, and on the other side you need to subscribe it at the substation and say, okay, I would like to subscribe the charger of system number 1. This is just the ACU bus ID. Okay, first thing, this needs to be done if you have a main station and a substation. This needs to be done all the time. Substations needs to subscribe the charge of the main station. If you don't do it, you will see a failure message in the substation because there are no BCM values. Next thing, you can also publish or subscribe ACU inputs. Okay. So the ACU inputs, these are the 8 inputs I mentioned before, 6 here and 2 here. And in this example, we would like to use input number 3 for block to block the system, right? If you say publish, all substations are able to subscribe it. Now you can block the system at the main station and the substation subscribes the input number 3. That's in general very easy. If you have a big system and you have many published and subscribed modules and inputs, it can be a little bit hard to understand the programming after a few years. But that's all. Publish it here and then you can subscribe it at the substation as well. One very important thing is, if you subscribe an input, then physically this input is gone. You cannot use the physical input on the ACU module here because you already use it subscribed as a virtual input, right, from the main station. So if you subscribe an input, you cannot use the physical input. And last but not least, the publish and subscribe function with 3 PMIO modules. So if you would like to turn on this luminaire here by pressing this button, you need to publish this module. Important, you need to publish the 3 PMIO module, and then you can subscribe the whole module. You know, all the inputs can be subscribed here as a virtual input, as the virtual 3 PMIO module. And if you subscribe it, you can easily program it however you want. I hope this you was able to understand what I mean. Okay, so let's talk about the visualization and substation overview and stuff like that. If you connect the systems together with the ACU bus, like you see here, you have a main station, 3 substations, right? Connected with the ACU bus, you have the normal substation setup we all know from the ZBS technology. Sorry, these pictures are in German still. I need to change it. You have the substations and the main station. If you have it like that, you can go to the main station and go to the substation setup, and you will see the status of the substation here. It looks like this. Go to the substation setup, system number 1, for example, and there we go. There's a substation setup. The HMI mirrors the HMI of the substation, okay? That means you can see the first screen like you would stand in front of the substation. This is the easiest way, just connect them together with ACU bus. Next step would be you have one system which is connected to the Ethernet, and the substations are connected with the ACU bus. Then you are able to connect yourself to the main station, to the web page, but you are not able to see more detailed information for the substation because these substations are still connected with the ACU bus only, which means you still see only the substation setup, which mirrors the HMI, right? You can see like this. You see status information from the ACU bus ID number 1, for example, and the status information, but you cannot see anything else. When you have the main station connected to the Ethernet, you can connect yourself with your browser to the main station and see it on your web browser as well. But that's all you see. The best would be if you connect all the systems to the Ethernet, because then you can reach each system's web page. Okay, you can connect to this system, to this, or to this, easily by enter the IP address to your browser, and then you can log in yourself and do everything like you would stand in front of the system. The standard IP address for the system is this one here. It's 1.150. Very important is this edition /webvisu.htm, because otherwise you are not able to connect or to see the overview. So this is the setup you need if you plan a vision guard as well. Just a quick reminder. When you use a vision guard and you would like to have a system connected on the vision guard, you need an Ethernet connection to all the systems. This is not enough. This is not enough to see all the systems on the vision guard. So this is different to the ZBS technology, because on ZBS, this would be the LON CGS bus, right? And there we go, and then everything's good. No, we need Ethernet connection to all the systems, additional to the ACU bus. Okay. Perfect. If you don't know the IP address, you can easily read it out. Go to the HMI, log yourself in, and check the IP address. And yeah, then you're good to go. Perfect. So yeah, this is the point where I would like to switch to the live demonstration first, and later on we can cover the PC software as well. Do you have questions regarding one of those slides, or can we switch to the demonstration? I have question. I did not hear any sound due to the question, but I think I covered it. So the question I got here is what wireless technology we use for battery sensors, Bluetooth or Wi-Fi or something else. Well, as I said, it's a Zigbee network. It's a wireless Zigbee network, 2.4 gigahertz. You know, it's like your wireless at home, yeah. Okay, so then I would like to go on with the live demonstration. So as you can see here, this is just the normal web browser, and you can connect yourself to this system. I have a system next here on my desk, you know, implemented in my home network right now. I would like to show you what happens when you try to connect yourself to the system without the addition, just the IP address. And there you can see he tried to connect and says, oh my God, no, I cannot connect. That's because this additional information /webreso.htm was not there. So if we use this as well, you can see perfect, I'm connected now. This is what you see first. This again is the same overview you would see if you would stand in front of the system. So if you go on site and turn on the system, this is what you can see on the HMI. Everything we do here right now is done live. Okay? If you change the program, it's immediately changed like you would press it with your fingers on the HMI. Okay. So first of all, you can see a general overview and the wrong language. So I would like to change it, right? We don't like to have it in German here. I would like to have it in English. There we go. Good. You can see a general information. We have some failure. This is general basic information. The mains are okay. So if I would have a mains failure right now, this will turn red. The name of the system, you can see that the automatic function test is disabled right now. You can enable and disable the function test in the menu. For sure, we can see the date, and we can see some battery information. Unfortunately, I'm not allowed to install a battery rack here in my home office. So yeah, we need to work with this battery parameters right now. On my test rack, I will connect to a dual guard system, which is located in Zoast as well, to show you some battery block sensor monitoring and stuff like that. But I will do it later on. Well, now I can do it right now. Let's go. You know, let's do it here on the system in Zoast. It's okay. Okay, so now you see battery parameters as well, right? You see the charger voltage, you see current 0 ampere right now, the capacity, and you see the temperature. Main says okay, everything's good. Next function test on Sunday in this case. So if you press somewhere here, maybe you can hear it. I click the button right now, nothing happens. Doesn't matter where I click because we need to log in. To log in, you need to use this button here on the top right. Just press it and use your login information. So as I mentioned before, the login is admin and the password is Ethan. This is a standard login. This should be changed later because it's, yeah, you can see it in the instruction manual as well. Okay, so if you log in for the first time, you will see this page here. The system asks you to change the password. I would like to keep the password. Okay, and now I'm fine. You can see we are logged in as an expert right now. The username is admin, and you see a clock. From now, we have 9 minutes until the system logs out automatically. When you do the web-based programming, it's enough to move your mouse cursor and the timer will reset all the time. If you stand in front of the system and do the programming on the HMI, you need to press a button for sure. Now, because we are logged in, you can press wherever you want to reach the first menu. The first menu, as you can see, is just a status menu. You can see just status informations, and this is the menu the normal operator would see. He won't be able to see anything else, just status informations. And I would like to cover all these menus step by step because some of them has new functions and new informations. And so let's go through it step by step. I think that's the best. First of all, the charge and battery state, where we can see some data, temperature, voltage, current, whatever. We can see this little information here, pub, which means that the charger is published right now. Okay, substations are able to subscribe this battery information to work with it. We can see the last duration test time and software informations. It's in operation. We have only one battery string active, so we don't use the 4 battery string monitoring I mentioned in the slides before. Just one battery string is connected. If we would have a deep discharge or isolation failure, you can reset it easily by pressing one of those buttons here. Okay. Let's go to charge modules and take a look how this looks like. We can see that only one CM 3.4 amp is connected actually. Okay, there's nothing else. If you press this module, you see basic informations about it, status information. You can see that we don't have a failure. There's no current actually goes to the batteries. We can see that the module works for 8,200 hours right now. Temperature informations. It's quite warm there in our training room. Nobody's there. Fan operating hours, 16. Fan MTBF means mean time between failures. And this means that after 60,000 hours of operation, you need to think about that the module might go broken in the next days, weeks, month. Maybe you are lucky and you have a system where the fan works 100,000 hours, but you know what I mean. 60,000 hours is the mean time between failures. Again, we see some software informations which are quite nice because the customer can now easily provide informations and see software informations without destroy the programming, for example, without do changes to the program. So I think this is quite good, quite nice, good overview. Battery block monitoring, let's talk about this, or let's show it there. As you can see, we have 18 battery blocks. Unfortunately, this is a test area, okay, our training room. As you can see, somebody played with the system, changed everything to 0, 0. Normally, you would see something like this, battery string number 1, block number 1, okay. Could also be battery string number 2, block number 1, and so on. See again some software information. You can see the average voltage and the average temperature of the system. And if we go to one of these sensors, we can also see normal values for the maximum voltage, the rated average voltage, the lowest voltage, temperature, and again, what's the average voltage in total for this battery block. If you take a look to this, the average voltage is 13.65 volt. If you look at this delta U, you see that the actual temperature is a little bit lower, in detail minus 0.37% lower than the normal rated average voltage. Okay, so as you can see here, this is the difference from the average voltage. Okay, values just switched. As you can see, now we have 13.75. So the battery sensor just received new data from the battery sensor, right? And now we have 0.95%. I mean, that's very low. Everything's good, but this is how it works. You can see how long the battery block works: less than 20 degrees, or between 20 and 30 degrees, and upwards to 30, 40, as well as 40, 50, and higher than 50 degrees. To be honest, if you have these temperatures, I mean, we're not in Australia, right? But could be, then you have a big problem. Maybe there will be some changes in the future, but yeah, right now, most of the time it should be between 20 and 30 degrees. Okay. So just status information. Let's go to the circuit state. If you go to the circuit state, you see all your SKU modules which are activated right now. You can see that the SKU modules are addressed from 1 upwards. 1, 2, 3, 4. We missed number 5, no problem. And then number 6, which means you don't have SKU module 2/4 anymore, or 3/5. You can program and activate each module absolutely free. You can assign the last SKU as module number 1 if you would like to do it like that. Feel free to do it however you want. You could say that the internal SKUs now are working like external SKUs in the past. Feel free to assign them however you want. And then if you go to circuit state, you see general name, general information, what kind of SKU do we have? Again, software information, quite nice. And you can see the status. The system is blocked right now, so you see that the circuit is blocked as well. We don't have operation right now. You can see the name of the circuit, training, calendar week 15. Okay, we need to switch over because my colleague is doing a training right now, or later. And yeah, then you see status information for the circuit. I will switch to my system here on the table again. 1 second, because then we can do some switching, and yeah, we can do some tests as well. Just open this. Circuit state, there we go. There's our SKU number 1, right? And hopefully this works now. Let's go. So there you can see in general some informations like name, monitoring method, as well as how is the SKU programmed right now. Do we have luminaire set up, or do we have the whole circuit programmed as maintain mode, non-maintain mode, whatever? Yeah. Here you see IGBT error. The IGBT error was implemented in the SKU 4 times 1.5 amp in the past as well. Now we have it here in the 2 times 3 ampere SKU as well. If you would like to, you can easily jump from the circuit state to the luminaire state just by pressing this button here, and then you can see the status of each luminaire. As you can see, each luminaire has the same name nearly. Let's go to it, And there we can see name, first floor, we have an information test, and how is it switched on and off. Actually, it's switched with the 3 p.m. IO input number 1. There we go, now it's back. I just switched it back to normal operation. There we go. So now we have a normal luminaire, which is green. You have general information. You can write in the type, the category if you would like. You can also write down the power consumption of the modules, of the luminaires. Feel free to if you want. Okay, so that's the circuit setup luminaire state, circuit state luminaire state. Let's talk about the 3 p.m. IO state. There we go. As you can see here, we have just one 3 p.m. IO module connected right now. Okay, sorry, just missed something. We have a 3 p.m. IO module right now, which is published, which means this module can be subscribed from other modules as well. If we go to next, no, we don't have a subscribed module right now, which means the whole module can be subscribed from a substation, for example. If we go inside, we can see each input and the actual status. If I switch input number 1 now, you can see directly that it changed on, off. If I simulate a mains failure, you see it like that, right? It's a red symbol. So everything is very quick, very fast. And yeah, in case of a failure, let's say you have a mains failure, go to home, and you have a customer, he will reach this very easy because he needs to go to the menu, and then he's, okay, now we have many failures, but then he see, okay, 3 p.m. IO state is red, just click on it. Okay, my module number one is red, let's go. And then you see there we have a mains failure in the sub-distribution board number 1. Okay, so troubleshooting is very easy there as well. Let's go on with the ACU state. This is a new module, a new menu, because we did not have the ACU. We have some software informations again, some information if the module has a failure right now. And we can program, or we can not program, we can energize and de-energize the relays. You know, these are the 4 relay outputs. You can check if they still working properly, as well as the buzzer. I mean, nobody uses the buzzer, but if you would like to yeah, turn it on, you can check if the buzzer is working right now. But let's go on to the inputs. There we go. ACU state inputs. You can see input number 1 to 8. Input number 1, let's start here, is a normal S3, S4 loop. It's programmed for mains failure, right? And it's published. This means that this input can be subscribed from a substation. Let's jump to this one, input number 4. The input number 4 is a subscribed input, which means the physical input on the ACU has no function right now. And yeah, if we would have a substation with this address, then this input will switch on as well. Okay, so let's say if we have a mains failure there, I just simulated, there we go, we have a mains failure sub-distribution. Switch back, everything's in normal operation. Okay, timer BMS switch. Here you can activate or deactivate virtual BMS switches. If you activate them all, or if we just activate one, you are able to turn on or turn off luminaires with this switch. Because we don't have function keys anymore, you can do it with the HMI right now, turn on or turn off everything with the normal switch, with the virtual switch here. And yeah, you can use it if you would like to do, as well as you can simulate timer 1 and timer number 2. PSU state, let's go through this. Here you can see we can have a maximum of 5 PSU modules. In this case, we just have one PSU module activated. Let's go to it. We can see we have an AC module failure because the system has an AC module programmed, but actually the AC module is not installed. This is what I mentioned before. You can see the failure message here. You can see again some general informations. IM current and IM voltage is for the measurement of the intermediate circuit for the AC module. So this voltage needs to be higher than 280 volts right now. It's less than 280, and that's why we have this AC module failure, right? And in general, we have some environment temperature, hotspot temperature, stuff like that. I think that's clear. Okay, last but not least, here we have our group device state, where you would see the substations. As I mentioned before, you have a maximum of 120 substations. If you check it, it looks like this, right? You have a general state information like you would stand in front of the system, and you can check the functionality of the system. Good, let's go to the menu and to the programming. If you press the menu button, you see one button which is called service information. Service information is good for us if you do some troubleshooting and you might have some problems you don't understand. We can check this window. These are informations which are not that much necessary. The important informations are on this right side here. We have an application version and a visualization version. These two versions are very important because it's a new product, so there will be some updates in the future, some new features and stuff like that. So maybe we need to check the actual software version. So if you have a problem and you write us an email, it's maybe good to send us a screenshot of this page as well. OS version is just the operating system. When you don't know the IP address, you can easily check the IP address of the system here. In this scenario, we have DHCP active. So this is the IP address my router provides right now. Let's go back. USB. USB means you can copy and save the config from or to a USB stick, whatever. If you program it with a PC software, you transmit the data with this here. For example, from USB stick, then you see SDA number 1, which is the USB stick. There we have test, and there is a config file you can now load. And again, you can also save the configuration file. Very important, eject the USB stick all the time. If you don't do it, you will have some, you can have some problems when you try to read the USB stick the next times. It's not bad, so nothing goes broke, nothing goes faulty or broken, whatever. But you should eject the USB stick the whole time. Okay, the function menu means you can do some functions. As I said before, we don't have the function keys anymore, so you can start duration test, function test, and stuff like that. I don't want to cover all of it, block the device. It's quite nice that you have functions that are like non-maintained luminaires on here, or FT without forerun, or with a short forerun time, because this needs to be programmed in the ZPS unit manually, right? So now this can be done with the functions menu. Let's jump to the circuit setup. So if you program a system, you activate your SKU modules, and then you would like to program it, right? Then we still have our circuit setup and our luminaire setup. It's just a new look. If you go to the circuit setup and to the SKU module, you will see something like this. You can see the name, you can change it, right? Training 44, and there you can see everything is very quick. You can easily do it with the web page. If you don't if you're not 100% sure that this is the correct SKU, you can press this flash button. If you press this, the SKU will start blinking. Okay, so the LEDs of the SKU will start to blink, to flash. You can see the programming of the control unit of the SKU directly. Switch 1 is luminance setup, switch 2 is maintain light. Let's go into it. You can change it. Each button, which is brown like this one, is activated. So if we would like to do a luminance search here, we can switch it to reserved circuit or current value monitoring, whatever you want. If you change it, you see this green bar here. This green bar means that during this green bar is shown the communication between the SKU and the ACU is in progress, and here only if you see this bar, the program is saved. Your changings has saved. You can write down a name, whatever. Let's go to switch number 1, because this is what we do. Normally you choose maintained, non-maintained, or by luminaire setup. Most of the time we use by luminaire setup. You can also say, I would like to use an optional input. In this case, we only have optional input number 4, which is programmed as a switch, right? You can say, oh, I would like to use a BMS switch. This is one of the 16 BMS switches we activated, right? Or you can activate a timer number 1, timer number 2, and as well, you can activate with this big one here on the bottom button. You can activate the 3 p.m. IO module. You can turn on the whole circuit with the 3 p.m. IO module. But we would like to stay by luminaire setup on switch number 1. Switch number 2 is maintained like battery. We all know it from ZBS. If you would like, you can put in an information text like prior registration required for access or something like that. Doesn't matter. And now you can jump to the luminaire setup easily for this circuit. Now we are in the luminaire setup. If you would like, you can add new luminaires. You can delete luminaires, whatever you want. Let's go to luminaire number 1. We would like to configure it. General information is clear, right? As I mentioned before, you can also category the luminaires, whatever you want. Yeah, EI is not correct. It's just a new database. Okay. You can change the switch, non-maintained mode, maintained mode, whatever. Let's go back to DLS mode. And there you can choose input number 1 to input number 5. We would like to switch it with input number 1. There we go. Switch number 2, no function. You can also say switch number 2 should be input number 2. There we go. And now you have switch number 1 to input number 1 and switch number 2 to input number 2. Very easy, I think, right? If you would like, you can copy this now to the circuit. You can copy the name to all luminaires. You can copy the switch to all luminaires, and you can copy the whole config to all luminaires. Let's say we would like to copy the switch. Just press this button. Module programming is active. Right now, he is programmed all luminaires to the same switch. If we go back and double check it, we should see, there we go, this luminaire is configured the same. Okay, so if you keep this in your mind, you can easily program very, very quick with the web page as well. As you can see, many data now for each luminaire. Now he's finished. Okay, double check. There we go. Programming for all luminaires is the same. And that's all. Circuit setup, luminaire setup, very quick, very easy. We all know it from ZBS. It just looks a little bit different. Let's talk about the 3 p.m. IO TLS setup. There we can search new modules if we want. We can do the configuration of modules. We can easily add or delete new modules. And if you have what's the name? Sorry, I missed the vocabulary. Yeah, you can use the 3-phase combination. What's the name? 1 second. Systems that are selective emergency operation. Okay, if you have selective emergency operation, you can also do a three-phase combination. And here I see here that this is not translated correctly because it's combination. Just write it down. Phase combination. Okay, there we go. So yeah, you can do the three-phase combination we all know from the ZBS technology to link more than one 3PMIO together to say they should switch together. But let's say we would like to configure this module, go inside. First of all, we can choose a name and information text, and then we have to say, would we like to publish it? Would we like to subscribe it? If we would like to subscribe it, from which ACU module and which 3PMIO module there should we like to subscribe it? Or is it just a local thing we don't like to publish or subscribe it? Then nothing is pushed here. Let's say we would like to publish and then go to input name. There we can choose input names very easily. Test, there we go. You can easily change the change the names for each input. This is how it works when you publish a physically module. If you would like to subscribe a module, I recommend to choose an address which is at the end. Let's say you have the first 3PMIO modules, they are published. If you have a module which is subscribed, I recommend to do something like this. Module number 20, for example, go to configuration, say subscribe, choose the ACU bus ID and the 3PMIO module you would like to subscribe. And then you have something like this, you know, the first modules are published, the last modules are subscribed. These are just virtual ones, so nobody will try to find a module which has number 20 because it's not there, right? Here, this is just my personal point of view. I recommend to do it like that. Okay, so let's go one step deeper to the basic setup. Charger, battery setup. So first commissioning, or when you change the battery type or you change batteries, you should check the battery setup anyway. You will go to charger battery setup and check the configuration there. You will find min operation time is clear. The DT end is rated operation time, which is quite nice. It's good. You can change it to deep discharge, for example, as well. 60 minutes is our rated operation time right now. That's good. The battery setup, there we program the float voltage of the system. You don't need to change the float voltage with the BCM service pin anymore. You do everything in the menu. Just enter the battery capacity and, as you can see, the trickle charge, which is the float voltage in millivolt per cell. Let's say 2200. It's too low, right? 237 volts. It's not good. Let's go back, 228. There you can see you cannot miss it. I mean, first it's a change to do it in millivolt per cell. But as we all know, we need to have a system for each purpose, so for special systems as well. And due to this configuration, we are able to change or to have a system in each scenario. Let's say we have a different system. In this case, now we have 36 battery blocks, but normally you have 18 blocks, right? There you can see that the float voltage is now 123. That's wrong, absolutely. But the trickle charge is okay, 2.28 millivolts per cell, which means multiplied by 6, right, would be the float voltage for each battery block. We see that this value is wrong here. We have 3, we need to change it to 6 cells per block because a 12 volt block has 6 cells. A 6 volt block has only 3 cells. And this is how you can change it, right? You can do some strange things here as well. Okay, 15 is not possible for sure, but yeah, take a look on it. Very important that this is filled out correctly. After you did this, don't go to the BCM module and change the trigger charge on the BCM module manually with the BCM service pin, because this would cause that you have different parameters in the menu than the BCM is really, providing to the batteries, right? Okay, let's go to general setup. Information text is clear, serial number, don't need to do anything there. And there you can change the number of strings. So as I mentioned before, due to the requirements, we have a BCM.1, which has the possibility to monitor up to 4 strings. Most of the time, I think we have systems where we use just 1 string, so number of strings is 1. BDM BBS is not activated at this system right now. I have to switch to another system for this. Let's go. Hopefully he's not at the system right now. Easily jump through it. Charger battery setup. There we go. BDM BBS. This menu is only available if a BDM is activated. My system here, you see BDM is not activated, so I cannot click it, right? The system which is located in the company, there is a BDM connected, so I can change the parameters here. And there you can see that the warning and error level voltage for the voltage and the temperature can be adjusted manually. I can say, oh, I would like to have it at 15%, for example, not 10%. You can easily change it. You can deinstall all BBS, you can search new BBS, and if you did search the BBS and you would like to set it up, just click BBS setup, and there we go. For example, you can go into this battery type, which is now named as 0/0, which is wrong. You can go inside. When you're inside this menu, the BBS sensor will start flashing. So you will see, okay, this is the BBS sensor I'm working with right now. And then you can say, okay, this is on string number 1, and this is my battery block number 14, for example. It changes, and easily, there we go, we did program it. It's quite nice. As I said, this is a testing system, test area, training room, so somebody played with it. 124 is absolute wrong, okay, but yeah, this is how it works. If you would like, you can delete the temperature history to get a new history there if you changed the battery block, for example, and you can also delete the whole BBS sensor, whatever you want. Okay, next, publish and subscribing. As I mentioned before, you need to publish this charger. If you have a main station, you have to subscribe it if you have a substation. And yeah, if you don't have anything, right, you don't need to publish it anyways. But in this case, we need to publish it. With the DualGuard software 1.4, we are also able to use an external energy source for systems and for scenarios where you have a DualGuard substation connected to a ZBS main station, because this is only possible since, let's say 1 month. Okay, before we were not able to connect a DualGuard substation to a ZBS main station because we needed to subscribe the charger. So in this special scenario, you can now subscribe, but say, okay, this is an external source, like a compatibility mode with ZBS systems. Last but not least, here we have an expert setup. You can allow boost charge. For sure, we would like to allow the boost charge. Fast battery interruption check. If this is activated, it just takes 1 minute for the system to react to an interruption. If you deactivate it, it will take 5 minutes, because each, there's an interval where the system checks the battery string. This is 1 minute, this is 5 minutes. That's all. You can activate or deactivate the boost charge during the fan error, and you can change shunt parameters. So especially if you change the shunt parameters to wrong values, let's say you do not 100 millivolt and 100 amp, you say 50 millivolt 100 amps, the current you will see is wrong, it's absolutely wrong. So this needs to be, if you change this, you need to be 100% sure that the measurement shunt is the correct one. Okay. Test setup, I don't think I need to talk that much about it. You can enable and you can disable the test. You can change the distance and you can change the FT lead time here, right? Lowest possible is now 20 seconds for each normal function test. Duration test, the same. You can enable, you can disable it, and you can change the distance in month. I will jump through it, go to logbook setup now. If you would like, you can check the last entries, right? The last entries of the system. To be honest, if you would like to analyze the logbook, I prefer to use the PC software because it's easier. It's very hard to check this. Download logbook is a function which is normally not activated. This can only be activated with the service entry, service dongle. Okay, sorry, you can delete it for sure, and if you activate the analog log, this analog values will be as well logged in the logbook. It means voltage and current will be logged in the logbook, and you can check these values later on during the battery and the boost charge mode. ACU setup. Here you can set up your relay outputs, relay 1, 2, 3, and 4. If you load the default values, you have the functionality if you would use a F3 interface. Relay number 4 is free programmable, and for sure you have your buzzer if you would like to use it. Input setup is more important. As I said, you have 8 inputs in total. You can program it however you want. For example, one is now mains failure, publish and subscribe. I think I already mentioned it. Functions you have is switch, inverse switch, manual reset, reset deep discharge, function test, duration test. You can cancel function test, duration test, block the device, and so on. So many functions here, external isolation monitor, external battery monitor, and stuff like that. So feel free to use it however you want. PSU setup, as I mentioned before, PSU is an intelligent module. You need to activate it and you need to deactivate it if you don't use it. Here you can activate and deactivate the AC module monitoring as well. So we deactivate it now because I don't have it here. So you can delete it, and for sure if you replace a PSU module, you need to activate the new module again. Okay, activation process is the same like ZBS, so I don't think we need to talk about this. Last but not least, in this menu we have BMS setup. The BMS setup is only needed if you would like to run a vision guard. The vision guard is a different topic. We cannot cover the vision guard topic in total here. I would like just like to tell you that this is the only menu you need to program in the dual guard. You need to enable the MQTT protocol and you need to enter the broker URL, username and password. But this is a different training. Broker URL is the same if you know CG Vision. The broker URL is the IP address of the system where the vision guard is installed, right? And the username and the password is created in the vision guard. It's very important. So this needs to match, and that's all. Keep lifetime, port, encryption mode, and stuff like that don't need to be changed because we can use the standard values normally. Here you can enable or disable the switches. I mentioned it before, the digital, the virtual switches. You can enable it in total or you can disable it in total to program it if you would like. Let's go to general setup. So timer setup is clear. I think you have 2 timers, right? You can enable it, you can disable it, you can choose the time when the timer should start, the days and starting and the end. Easy. Relay module again as well. You all know the relay module CG4. You can still use it if you want. So if you would like to use it, you activate it and you see it here. Then we have our HMI setup, where you can set up the date and time, stuff like that. Don't need to talk about this. The brightness setup, we don't need to talk about this as well. Let's talk about the network setup. Very easy. If you have DHCP, activate it. If you don't have it, manually enter your IP address, subnet, gateway. If you would like, you can also activate the host name. Very important, afterwards, press the apply button, because the apply button needs to be pressed in this menu. Otherwise, there are some values in the back who are not written correctly. And we had some customers who did forget to press the apply button, because if you go out of each menu, normally this is enough. Go press the back button, because everything is saved immediately. But the network setup is the only one where you need to press apply, because there are many informations who are set there. And if you would like, you can reset the settings of the system, like the factory reset. Okay, user setup, user account control. As I mentioned, we have 4 different user accounts who can be assigned. And there you can see that we already have some accounts there. Let's delete this one. Let's this. The commissioning on site, or if you would like to create an account for the customer, you just need to press one of those fields here and then press this button on the right side. There we go. The name is test for sure. The full name is test. The password. As you can see here, we have some requirements: minimum 6 letters, capital letters, lowercase letters, number, and so on. As you can see here, if you have 2 of this, everything's fine, right? So I will need to repeat the password now. There we go. Okay, and last but not least, you need to say, what do we have here? Do we have an operator, untrained specialist? You can have an instructed specialist or an expert. I would like to show you the overview as an operator. So what the customer would see if you have just an operator account. That's why I marked this one. And I would like to add the user. Press OK. It jumps out of the whole menu. And there we see we have our test account. We can directly check this, press home, log out, and see if it works. So the test account was, test. And the password, there we go. As you can see, the customer is asked again to change the password, because you created the account for the customer. Now he should change it. We would like to keep it. We go to the menu, and there you see that the first menu looks the same, like you would be logged in as an administrator. You see we are operator and test, but when you press menu, you see you are not allowed to do anything else, right? You can see the service information, you can press USB, and there you can only copy the config, and that's all you can do as an operator. Okay. Easy. Jump into the menu, user setup. There we go. So this is user account control, right? You can delete, you can deactivate an account if you would like to do it. Yeah, whatever you want. The customer can do this as well for sure. You can say, okay, here customer, here's the admin account, please change the password. And yeah, customer can create it as well. The email setup, it looks a little bit confusing. Don't be stressed if you see this, because many information needs to be on one, HMI on one display. In general, you can split it down. So these are just the receipts who should get an email and which kind of information they should get, right? Server programming or server parameters are used to program the SMTP ports and stuff like that. For the main providers like Gmail and yeah, don't know, Outlook, T-Online, stuff like that, we have the values already there. As you can see, this is what's changed sometimes, the port, the encryption mode, because yeah, the providers changed some values. For sure, they changed some values in the future, which means this will not work the whole time. But from now on, actual state, if you have a GMX account or if you have a Gmail account, you can use this and everything is fine. If you have your own provider, you can easily use your own SMTP port here, but then you need to change the port to the port you need. For sure, you need to choose the correct encryption mode. Again, we use SSL and Start DLS, right? Both is possible, as well as, yeah, do you need a different or a separate authentication? Like, is the login enough, or do we have more authentication modes? You know, you need to have the IT knowledge to do it. Charset UTF-8 is standard. We also work with ISO 88591. UTF-8 should be absolutely standard for all the providers, but yeah, this is how it looks like. You can choose if you would like to send the IP address of the system in the email header, because some of the providers, if we press it, let's see, so there we go. T-Online, for example, if you send the IP address in the header of your email, then T-Online will block the email. So some of them are blocking it, so you can choose it if you want. And you can say, okay, I would like to receive a status email as well. I would not like to receive a failure message when we have a failure, like mains failure, for example. I would also like to have once a week, let's say on Sunday, right, on 8 o'clock, I would like to have a status email. And the status email gives you a general overview of yeah, how the status of the system looks like. Okay. Then general setup, HMI setup. We talked about user setup, email setup. Here, in general, for the dual guard, there's only one more menu. It's the system setup. This is the last one. There you can choose the ACU bus ID, 1 up to maximum 120, right? Safety source is only needed if you use a vision guard for monitoring, because then you say, okay, this system works with the main station and the charger of system number 1, for example, and the other system with the charger of system number 2. Because you can imagine if you have a vision guard system with 100 systems and let's say 20 of those systems are main stations, you need to have information which substation works with which main station. You can activate delay ons main return as well as FT after S1, S2 and selective emergency operations, stuff like that. The functionality of those functions is clear, right? If not, please ask. I think because you all have good ZBS knowledge, I don't need to cover the function, what manual reset is, selective emergency light and stuff like that. Okay, name information is clear. Do you have questions regarding this overview, the dual guard programming with the web page? Okay, good. So what do you think? Do you like to program the system with a web page overview, or would you like to program it with the PC software? What do you think is your personal thing there in your business? Hello, I'm still there. Okay, don't look like you're there. Okay, uh, is the CBS PC software? Would you like to see this software as well, or is it enough for you? I see a chat message. 1 second. More or less clear. Okay. Yeah, is the PC software important for you as well? You will see it absolutely, yeah, looks the same like ZBS. If I jump in, you can do all the changes we did on the web page as well, just in your office. When you're not in front of the system and you don't have remote access, you can program the inputs, for example, whatever. And if you do the programming of the SKU modules, important SKU is ATSD. ATSD is the English word for SKU. You can select your SKU type, go to configuration, and this, I think you all know this one, because this is the same we had in ZBS technology. Tried to, use the same overlay. The question is, what you like to do later? Would you like to program with the PC software or with the DualGuard web page? This depends on you. Okay, do you want more topics in some special parts? Because I think, correct me, but if you know the ZBS, you are able to work with the DualGuard as well, or am I wrong? So if you need more information, just let me know what kind of information you would like to have. Otherwise, we are already finished, because not many questions right now. So I don't like, I don't like that it's boring. Okay. Yeah, then I just need some information with special topics, because today should just be an overview of the DualGuard system and what's different. So if you don't have more question right now, that's all. I think we covered everything. Yeah, the PC software is one thing, but okay. Everything's okay. I just read the chat. Good. Okay, then nothing to say. Thanks for being part today. If you have questions, if you need special information, just write me an email. But I think with knowledge in ZBS, DualGuard is good for you as well. We have good new features, some changes on the modules, stuff like that. Then I'm finished for today. Thanks. Have a nice day. That sounds good, Nikolai.